Hey folks, and welcome yet again to another edition of Helium Hacks Happy Hour. My name is Travis. I go by TT over on the Discords, and I will be your host this evening. So, how's everyone doing? I'm back home now. We were in Austin this past week and broadcast from there, but I think hopefully we have everything plugged back in correctly. And is audio okay out there?
Yes.
Hopefully. All right, cool. What's up, Scott? We
Yo.
have a special guest for you today. Scott is going to be with us talking about Hardshare. And this is something that, comes up time and time again on the program. And yeah, we're excited to get a little more insight into what this is and what it allows us to do. So, Scott, welcome. Thanks for joining us.
Thanks for having me.
If this is your first time on the call, which I don't think it is for anyone here, but if it's your first time, go ahead and unmute your mic, turn on your video camera. We want to see your pretty faces and introduce yourself. Say hi. This is a call it's a very casual call for developing on the Helium network. And, we talk about developing end nodes, talk about, we actually give away what we're going to be talking about a little bit tonight with the whiz blocks. If you're looking for some hardware to develop with. So we have these kits and they're ready to be mailed out. So if you want to pitch an idea, if there's something you want to build, just, unmute, let us know. And I'll make sure that you have some hardware that you can work on. So, with that being said, we've got some things coming up. Next week, and this is kind of cool, the folks over at HiveMapper are mailing me a device to tear apart. So that should be interesting. I've heard that they're pretty epoxied up, and so I'm probably going to have to at least start cutting it open out in the workshop rather than in here. But we'll figure out what we have to do there. It comes in the mail tomorrow, so that should be neat. If you have any questions, for that, please let me know. If you have anything you want to present on hacks, please hit me up in Discord. We have a channel, Helium Hacks Happy Hour, over on Discord, and anyone can post in it now. So feel free to let's kind of keep it on topic, about this call or about shows that are, happening on this call. But, please jump in there. We also have the community project that is going on right now. And if you don't know what I'm talking about there, we have a video on the Helium Hacks Happy Hour YouTube playlist that you can kind of get the full rundown there. So make sure to check that out. I put an edit of last week's show up, and so that should be available. One thing though, getting some pretty potato resolution quality coming off of the Zoom cloud recording. And I found something out. There is a setting that says optimize for third-party editors. And I had that on, but apparently if you turn that off, you end up getting a higher resolution output. So we're going to try that. I'm also recording locally tonight as well. So hopefully our video quality will go up there. But just understand why it's been a little shady there recently. And hopefully we got that fixed. Yeah, okay, with that, I don't want to lose too much time. So, yeah, Scott, you want to kind of introduce yourself? Tell us about Re-Robots and the Hardshare project?
Yeah. So thanks. Yeah, so this is not going to be a very formal presentation. It's just going to be me giving a summary, and then I can go into some detail. But my name is Scott Livingston. I have been working for a few years on a system for sharing hardware remotely. Actually, I was doing this before the epidemic, and so before all the emphasis on remote access to stuff. Originally began with robotics focused work and then expanded to include other kinds of electronics devices and IoT devices. And in summary, I have a setup where I began by just hosting all the hardware myself, but then I quickly learned that people want to be able to access or support access to hardware that they have. And so I expanded the concepts and came up with the name Hardshare, which is a play on hardware. So I didn't make presentation slides, but I do have documentation here. So if you go to a website, which is called docs.hardshare.dev, you can see something like the following. Actually, I've been working on updating the docs for a while, and I just pushed these out. So if you had visited docs.hardshare.dev 1 hour ago, it would look fairly different from this. But the summary is that there's a system where there's some infrastructure that runs in some data center, pretty typical for software as a service kinds of projects. And there's a part that you run locally called the Hardshare client. And then there's a robot, or in our case, an IoT device, Helium compatible device that interacts with the Hardshare client, which then allows remote users to access it over the internet. So this is just an illustration of the entities involved. And one of the core concepts here is that anytime someone accesses your device, we have what is called an instance. And I'm open to changing the terminology, but this is the terminology I came up with a few years ago, and it might change one day if I get enough feedback that it's not clear. But essentially anyone who uses, so any remote user who goes through the system to get access to the hardware gets what is called an instance, which is supposed to be their time to exclusively use it. And instances follow these states. Not very important for this discussion, but the main aspect to consider here is that every time someone uses the hardware, it is prepared for them, then it's ready, and they can use it as much as they want, up to limits that the owner can specify. And then when they're done, there's a termination process that can clear the memory, prepare the device for the next user. And the other important point here is that access to the hardware is always through some kind of contained environment, and the details depend on the target device. For what we're talking about today, it's just going to be Docker containers. And so the remote users of the devices will be accessing the instance, but ultimately there's some host machine, and there can be filters, proxies, other things that manage the access to the hardware. So this is a conceptual view. This is all at docs.hardshare.dev. There's also a repository that is linked to from here. So there's source code here. As you can see, it is under active development. And okay, so what we can do to illustrate this point is go to rerobots.net. And so if you are an owner of a device, then you get an account on this website. And currently it's an invitation only kind of thing, because I'm just the person running it all. And so I want to work closely with anyone who's going to be sharing hardware through the system. But in summary, there's a management page. There are different devices that are listed here. We have one that Joey Hiller has been hosting for a while. It's basically so there's no photograph here, but it's a cube cell board. And I've shown this same device in some past demos, but we can look at it here, which is this thing. And so I just clicked on this link. We call these sandboxes. It's a special way to access the hardware that anyone can use. So I do not have to be signed in to this account to use it. And now I have exclusive access to this device. This is a cube cell board that is LoRaWAN capable. It also has a small OLED screen on it. And there's an example program loaded here in the left side of this editor, and then some buttons here to work with it. So this is a full terminal embedded in the web browser. And by the way, I think many people here, or some people here have already seen this stuff, so I'm just going to go through it relatively quickly, and then we can take the rest of the time to go into more detail about how you would set this up on your own hardware, or if you had your own device that you want to share. So basically, there's an example program here. It's from a repository that Heltech puts out. Kubecell, Arduino, they have example programs. Now that I'm looking at this, I don't see it. Oh, it's libraries, display. I can navigate to it. Examples, OLED, and it's one of these, maybe this one. So there's a drawing demo. So the source code that you see here, it might not be precisely this file, but it's one of these examples in the OLED folder. This file is shown here. And if we just push build in Flash, then the code in the editor, which you are free to have edited, will then be run in an environment local to this board, and then is uploaded to it, and it will start to draw in just a few seconds once it starts to run. So hopefully you can see now there's just some OLED screen drawing happening. And I said that any user can access this who has this special URL. So if I copy and paste this into an incognito window without any active sessions, then we get put into, actually, right. It does not have queuing enabled, but you can enable queuing. So what I will do is go ahead and terminate this. And when it's terminating, as I said earlier, there's a resetting process. So this is the management view here. But it's terminating. So okay, it's terminated. So now if we go back to this incognito browser that does not have any kind of active rerobots session, and we go back to that link, then we get access to the same device as an anonymous user. But we see that here's the board again. Here's a fresh environment for us. Okay, so that's the user-facing side of all of this. Now, if you wanted to host this kind of hardware yourself, do something like the following. So this is a terminal that is connected to a machine that is local to this Kubecell board that we have here. Actually, we might be able to see it, ls USB. And it's probably this UART bridge here. And so there's a Docker container running here. This is the environment. So we see Kubecell. We'll talk more about that in a moment. But basically, this Docker container is what this anonymous user sees here. So this little terminal, the text might not be big enough to see very clearly in the video, but okay. And there's a Hardshare client, which is, this is the thing that you get if you go to the repository that we looked at. So if you go to the rerobots Hardshare GitHub repository, which I showed earlier, and you install from there, or if you follow these instructions on this website and set things up, basically you get this client is already installed here. So this is a command line tool. We can see things like Hardshare status. We see that there is an active deployment. Also, there's some other noise with something that I might need to debug later. But anyway, you have a Hardshare client here, and you can get information like different environments that are configured locally. It looks like just a lot of data that I'm showing you. But what we can do is set up a new, well, we can do anything right now. We could create a new device and step through that together. Or we can do something else. let me first go to the management window on the website. So this is the perspective of someone who manages the device. So there's no active instance. If there was an active instance, we could delete it or make it stop. Okay. I have these terminals running with this environment, but I'm going to just close all this stuff out and start it up from scratch. Okay, so typically once you have an account and you have the Hardshare client, so Hardshare has a command called register, and default behavior only allows you to register one locally, but because I already have other devices that have been registered on this, I have to explicitly say that I want to register more than one. So I'm going to go ahead and register. All right, too many active instances. So what I'm going to do now is open up an administrative window that would give this user more permissions to register more devices. So there's something messed up with the shell here. I was doing some other work earlier that's making this % and pound sign appear. I'm going to sign out and then sign back in, and then clear the screen. And we're back. Okay, so if we have an environment or a device that we're done with, we can actually say we're going to be done with it forever. So in this case, it's called dissolving. We're going to dissolve this. And oh, interesting. I actually had not dissolved something in a while. So, okay, let's go the other route where I register a new device. Let me open up the administrative page. I think there's a better solution that I'll be able to share the screen for here. Okay, so here's what I'm going to do instead. Show you the perspective that you would have as a user. To set up this local client, you would need to create a key, or also called an API token, that you would have locally. I'm just going to make one for today. And actually, I'm going to revoke that one and make a new one and give it a name. So Helium Hacks Demo. And then I'm going to download it, E8E5. I'm going to do a fancy command to copy it over. Then I'm going to go back to the machine where we were just demonstrating, and then we see the key is, oh, here. So I'm going to remove the others that I have. And then I'm going to do Hardshare. Config. Okay. I'm in the process of revising some of these command switches, and so the new name is actually going to be add token, but this is a little bit of an older version of the client installed on this particular host, and it still has add key. So if you get this client later, it will be add token, and the current documentation shows add token instead. So now let's try to do the register again. And so we received a new ID. So now we have this new device that is registered. And we can get this device ID. It tells us where we were when we registered it. We can go back to the Hardshare management page. And we can look for the ID that we just had printed, and here it is. It would register today. So this can be called the kubectl setup for Helium hacks. Okay. So now, if we look at this configuration information here, we see that this is the web page for it. And we are the owner, or I'm the owner. And we have a C provider or a container called Docker, and it uses an image which is called HS generic. So HS generic is a Docker file based image that is shown in the Hardshare repository. So I'll go there right now to show you what it looks like. If you go to Hardshare and you go to the devices directory, generic, and then the simple file is this one. So it's just a Docker file that has an Ubuntu base, installs some stuff to allow the remote access and VPN, and that's basically it. And in this case, what we want to do is take this image and then modify it so that it has the toolchain already set up inside. So a typical way to do that would be to do something like Docker run locally, and then you can do this image name, and then it starts up. Oh, actually, what we want to do, okay. I'm going to open another terminal. I'm going to stop both of these. Okay, that was strange. So now we're back. And we're going to do bash instead as the command. And then typically what you will do once you're in this container is you can set up environments that you want to be installed. So actually, there's another image that could be used instead. If you go to the generic directory, there is a Docker file with platform.io already set up to run in it, but we can just copy and paste some of these commands in to this container and just run them this way. So it did not work the first time to install platform.io. I have an image that's ready to use if we cannot solve this quickly. But
What?
so, oh,
I am fine with either. Are we tacos?
yes, get tacos.
Hey Scott, this is Jason, gray hat guy. But so you could basically make your own Docker compose and like add a few different environments in there next to your Hardshare image. Is that what you're showing
Correct.
there?
Correct. Yeah, it's
Okay.
I'm gonna just make a new. I'm gonna copy and paste this Docker file so it's local to this machine. Yeah,
Yeah.
I'm gonna do a command like this. So now I'm just going to build the example from the repository directly and see if that helps us get past this. Oh, interesting. Okay, so this will take some more debugging. And I can say that if you would try to install a client locally and you encounter this, I can work closely with you to make it work. But for the sake of a presentation, I have already gone through a similar process before, and it is in this kubecell example container. So I'm going to go ahead and run it just to show you if you had followed these steps. It's probably something wrong with the base image. Looks like it's probably too old. But if I had a newer one, then it would probably succeed. In any case, I have this image that I had already built up that has Platform IO installed. It's the Platform IO. Oh, that's right. Platform IO version. And so you might remember when I did the initial demonstration of the sandbox and we ran the build and flash command, we saw that Platform IO could be upgraded. So I'm going to go ahead and upgrade this image just to show you what that would look like. And once that happens, okay, so now we're at the newer image. I'm going to open a new terminal. And this last step is a little difficult, but we're going to open up another terminal. And then we're going to save this new image over the previous image. So that now whenever someone runs the sandbox, they get the current version. And to remember the command, I'm actually going to go to a tutorial that is in the Hardshare docs for setting up an ESP32 board. And this tutorial goes through most of the steps that I'm doing now. But the one that matters is this Docker commit command, where we create this new image using the current image that we updated the Platform IO in. And then we're going to give it the same name as the image we were using previously. And that was it. Okay, there's not much of a difference. So sometimes this commit command takes more time. Okay. And now we're going to exit. And let me find the right terminal. So at this point, we have a new device that we registered. It's the D22 device here. The image is still configured to be the generic image, but the one we want is the image that we just updated, which is called kubecell example. So to do that, we can do hardshare config assign image kubecell example, followed by the ID of the device that we registered, and then we're set. So now if we do config L again and we scroll up, we can see the image is now set to kubecell example. One more thing that I want to show you about this kubecell example is that, so let me clear the screen so that you can see what was inside. Besides installing Platform IO, I also put a copy here of the kubecell Helium US 915 basic. So this is a demo that's ready to run in the US 915 band. And it has the example in it that we looked at before. So main CVP here is actually this example. So I'll just copy and paste this full URL and open it up in the browser. So this is the health tech automation repository. Here's the example we're looking at. And now going back to the terminal, this is just called main CVP in this example directory. But as you can see, we do not only have the C++ file, we also have other stuff, like we have a Platform IO INI file here that gives the configuration information. If you were doing Hardshare in a different country, you need to change this region to something else besides US 915. depending on which region you're in. Okay, so this is what is inside the image. Now, the next step is two things. First, I'm going to open up tmux, which you don't have to worry about if you're not familiar with it. But if you set up Hardshare locally, there are some notes in the tutorial about this kind of technique. We can do Hardshare, advertise, which is add, and let's go, we'll copy and paste the ID of our new device here. Actually, so add is only something that prints errors, but if we do a -v for verbose, then we get more information. So it's starting to advertise this device. And there's one more thing, which is we're going to attach a camera. So this allows us to stream a camera associated with the device or pointing at the device. You're able to do things like crop the image or share the image among multiple different devices. But here we only have one device and there's a camera pointing at it. So we're just going to do a full copy of it. So we just put the integer for the camera. But on Linux, these typically appear as different video files. And I just happen to know, actually, I'm not 100% confident. I'm fairly confident it's video 0. If it's not, we'll determine that fairly quickly. And I'm going to paste in the device ID again. And then we start the attached camera. So now let's go back to the website. Our device is all set up. And the next step is finally to do sandbox management page. We're going to create a new sandbox. This user interface needs a lot of work, but everything's there for us. So we're going to do Helium hacks 3 May as the name. And then we're going to say it's a cube cell drawing. Thank you, everyone. And there are different kinds of sandboxes for presenting the device. We're going to do an editor plus a terminal. Now, for example code, we actually did not need to have a copy of the full code inside the image. We just needed to have the base environment. So what I mean concretely is we can go back to this page with the repository and the example code. I'm just going to copy and paste this file of the contents here. And then I'm going to go back to the creation page, paste it in to this box. I want to give credit where it's due. So code is from, and I'm going to paste in this, a link to this source. We can do a little preview of the markdown. And, oh, interestingly, I don't see the preview. Okay. Oh, there it is. Thank you, everyone. Code is from this. So the markdown is showing like we expect. We have the code here. And the last step, the last 2 steps of this setup process for the sandbox are to say where we're going to copy this code from the editor into the container. So to see what that is, we can go back and start our terminal again with the image, and we can see where we want to copy the code into. So you might remember I showed you main.cpp. That's where we want to copy it. So I'm just going to copy and paste this path into the editor here and do main.cpp. And then we're going to call the label build and flash for H. And then the shell command to be executed when the button is pushed. This is difficult to remember, but if you go to the Hardshare documentation, there's an example of a command that works for this platform IO. It is right here. So Platform.io has some requirements around the localization character set, which is what these two leading variables are. You can look more to them later after the presentation, but basically we can just copy and paste this in. We're going to need to modify it because it has a different directory here, because the ESP32 demo has an ESP32 example folder, but we know that our folder is different and it's here. So I'm going to copy and paste it. So basically this command initiates Platform.io, goes into the directory of the project that we had prepared in the image, and then does a run upload command on it. And we can say the users will get 15 minutes each on this device. Now, here are all the different devices I have registered. The default is to check all of them, but we know we only want the sandbox to be associated with one device. If you have more than one device here, then anyone who goes to the sandbox will be linked to any of the devices that happen to be available. Okay, and that's all that matters for us for this demo. And an internal error occurred. Okay. Let me let's try to delete this. Okay. So let me see if I can identify what went wrong. And as I'm trying to debug this, this is all work in progress, though I was able to create a sandbox not very long ago, so it is a little surprising that it failed. Let me see if I can find the reason. $16. Let's try. So I think we can keep this. Okay, that succeeded. So the problem, and it's not obvious from that setup form, but one of the fields that corresponds to the button, let me go back to show you. The built-in Flash has a maximum length of 16. So we can make it something shorter, build for H, and then it'll work to save. But the build and Flash for 4H was too long for the database validation. That's an implementation detail. I can make it longer if people need or want. And so now we have this URL here. I can try to run it and see if we can get access to the device that we just set up. Okay, so here's the introduction that we created. There's the cube cell that we were looking at before. And we have the whole terminal here. Oops. And here's the example. And then we can do build for 4H. And it should succeed. So upgrading, it did not have to do an upgrade, but it was checking for an upgrade. Oh. Okay, so what happened is we attempted to upload, but then there was no port to upload to. So now let's go back to this environment on the host. And the last step that I forgot to do in the heat of the moment is to actually point to the device. So we can use a command here. It's called add raw device. So add raw device dev tty USB 0. And then we can go back to where we are advertising this. So lots happening at once, but I'm going to terminate this instance. And then we can see that the thing that we have running locally that manages access receives a request to destroy access and should be done with it soon. Should mark it as done. Okay. So now I'm going to stop this statement. I'm going to start it again. And now we can try to run the sandbox again. This time, the device should be added and then visible from inside the sandbox. Okay, so our little daemon here said the instance is ready for the user. We see that it is from the website. And we can try to do build for 4H again. So the fact that it's already uploading means that it does have access to the device. And then we see the same demo running again. Okay, now, well, I'll keep that running. And this will be the last thing that I'll show here. I'll go back to the sandboxes and I'll edit the current sandbox. And we can modify this example to do something else. So we can just, this is not a LoRaWAN example, but just to keep drawing stuff, we can leave that part. But instead of drawing lines, we can delete everything except the draw string. Helium Hacks Happy Hour. And I don't actually know what this computation does. Display. We have to look it up. But I'm just going to leave it. No, actually, I'll do 0. See what happens. And so this saves the template code. Now, if we go back to the sandbox and we refresh the page, then the Hardshare in ReRobots sees that we're the same user and we currently have access to the device. And so it doesn't do a new instance. It just gives us access to the same device, but it refreshes the template code. So if we scroll down, we can see where I made the change to the template code. This editor is also a valid editor, so we can do things like delete other sections of code or change them if we want. And now we can just try to build in Flash again. And if I change the code as I expect, the only output should be to draw Helium. Oh, okay, it goes off the screen, but oh, let me try to make it big. So Helium Hacks Happy. Okay. And that's basically it. And so now the default for a new device is it's not accessible to anonymous users. So if I copy and paste this into an incognito browser, we get a no devices are available now, which is what we saw earlier example, but let me go ahead and terminate the device so that we know it should be available to anyone. Okay, so if we had a device that we owned and it was being used by someone, it would appear down here on this page. So if I go back to the incognito browser and I refresh the page, we see that still no devices are available. So if we go back to the management interface here, and then we do something like Hardshare rules permit all, which includes anonymous users. Oops, let me add the device ID. Okay, let's try again. Hardshare rules permit all, and then we want to copy and paste the device ID here. Make it accessible to everyone. Then we go back to the incognito browser, we refresh the page, and then we see the anonymous user can now get access to the device. and it still shows Helium hacks. So there's more to it than that. Even though I'm a new user accessing the device, we did not set up something that is a termination script. So Hardshare config shows you that for these devices, we can set up a termination scripts. So here it's in the section terminate. I had made one from a previous example, but basically this vac.sh takes a program that I had created and builds it and flashes the device. So this particular case is an example program that has an empty dev EUI app key are all zeros. And this vac.sh then flashes that to the device. So you can add a terminate program like this to the program. And now if we look at the configuration information, we see that whenever someone's done with this new sandbox that we created, this vac.sh will be run, which will flash that empty or vacuous program to it. So we actually have to restart the daemon for it to take effect, like most changes to configuration. And so if I go ahead and do that now, and then I rerun this just to show you it works, and then I'll be done with the demonstration for today. So, okay, we see there's no program that was run because we just added that configuration. But if we go ahead and terminate, because we're done early, then internally, the daemon that's running on the computer that we host the hardware on says that it's running this termination command and that it completed successfully. So now, if I refresh the page and get a new instance, we get evidence that the termination program had run because now there's nothing happening on the kubecell screen. Okay, and that's basically it. So if you set up hardware that others are accessing, you can do other things, like you can edit you can pause access, and you can do stuff like coming back soon, set an away message, and then you can pause it. And then if we go back to this page that was viewing it, then there's just a message coming back soon. You can do more of a message than that, but basically you can control when anyone can access it. And also you can do other things when you want to make the hardware not available. And that's all I had to present. So that was just a very fast tour of setting up some hardware. If you're interested in this, you can contact me either to access hardware that I'm hosting or someone else is hosting. The kubecell we were looking at today was hosted by Joey. I have some WizBlock boards. There's also tutorial if you want to set up this on your own. If you have hardware and you have remote users, whether you know them personally or you want to allow anonymous access. And you can do other things too. So we did not go into some details here, but you can set up initialization scripts so that when a new instance is created, then you can prevent, or you can run some additional setup script that can do something that might be relevant to your hardware setup. And I think that is all that's important. It probably was too much information to remember anything. So I think the main takeaways here are that there's a workflow. Most of the process is from a command line tool, but I am available to work with anyone to set up your own hardware locally if you want to. And the documentation and code is available online if you want to browse around it. Okay, Travis.
Scott, thank you. This was fantastic. Do you have time for a couple questions here?
Yes.
Okay. One just note that sometimes isn't necessarily completely clear. If I'm doing a LoRaWAN, program here, then I'm using my own keys that I set up within console, and I see all of that data come through Helium console just like I would, in any other device, a device that I have on my desk. And so you still have your debug console, you have all of that capability within Helium console. Another thing, what is Blockly? I saw that come up when we were going through the config there.
Yeah, so I can show you. This will take just a second. Let me
Cool.
try to do the share again. So there's some work in progress to make an editor that allows you to develop with Blockly instead. So you should be able to see my screen now. And if we go back to this editor that we just created, oops, so it's a work in progress, but I call it Circuit Blockly. And if we save it and then go to the same link, that's right, it's set to away. Let's enable it. And then let's try again. Let me see here. Okay, we have that user I was doing it previously. Okay, let's take the quick opportunity to say that there's this other window, even though I switched it to not allow access anymore, that anonymous user did have an active instance on there. As the owner of the device, I can see them here. I can see which device they're accessing, and I can force their access to stop. So that's happening now. And as soon as that finishes, we can look at the Blockly. Take just a few more seconds to run the termination program.
Is that like Scratch?
It is like Scratch. Okay.
Good, I can get my 13-year-old to show me how to do it then.
Oh, let's see. Okay. Yeah, so actually the LoRaWAN and sensor parts are not here yet, but that is coming, or that's in development. So we can just do something like anyone can learn with Blockly.
Yeah, this reminds me a lot of that the Woqui software that they have for Arduino, where you can drag and drop and the code gets generated. A lot of the code has templates already.
Yeah, I've not tried the Woqui, but I've not tried the Blockly on it, but I will look into that. I did have it in the list of things that I want to try.
They
Yeah,
have Rust examples as well in the code, so you could go C, Rust, or Python, whichever way you want to see it.
It generates Rust from the Blockly. Is that?
It doesn't generate. The templates are preloaded, but then the graphics, I think, are generated from the code. I'm not sure how they're linked back and forth, but a lot of the stuff that I've used is like, here's the basic hello world template. And then you could add to it. There's some more advanced examples like shift registers and things like that. But yeah, they have a fair amount of library. I used it for first got into it from the Pi assembly language, PIOASM. It has a translator.
Yeah, that's neat. PIOASM. I'm not familiar with it, but I will check it out after this. Yeah, I wanted. So I'm doing this development from scratch. I want to from scratch, as in I'm making this new Blockly environment rather than using something like the Wakawi, if that's how you pronounce it, or some others. There are a few circuit or embedded development focused Blockly environments. And I have not found one that is ready to work with a LoRaWAN environment, but it's possible that one is out there and I've missed it. And so if anyone has leads, I'm happy to learn more about it.
Oh, just another one that I just thought of when you said that. NRF for the NRF desktop has maps. It's and yeah, it's really neat. Just I've noticed it 2 weeks ago.
Cool. Yeah, I'll check it out. I'm making some notes from this presentation, so I will look into that. Thanks, Jason. Yeah, so currently this just can print. It doesn't do much, but I'm going to add some upload or uplink kinds of capabilities here, and also read from sensors. So that's roughly where I am. But the Blockly editor is fairly comfortable environment because there's just a print, for example, or you can get other primitives, and then you can dump it in the trash.
Cool.
Yeah, I wish I had more already in terms of the Blockly, but it's coming soon. Maybe next week at
Nice.
the Helium Hacks, I'll have some more Blockly to
Very
show.
cool. So, question: if I want to set up my own instance, what type of system? I mean, this is what Debian based.
Yes. So this host where I'm doing everything is an Ubuntu machine, so Debian-like. And I have used, or I have run this on Fedora machines, which are Red Hat kinds of machines also. So in both cases, it's Linux. However, I made a lot of progress to rewrite the client so that it can run on other kinds of hosts. So if you go to the repository,
Oh, cool.
you can see that like the Python is the legacy, I call it, implementation. But there's one that's in Rust, which is the going forward one client implementation that we'll be using. And so I don't have a Mac to try it out on, but I'm fairly confident it will work on a Mac because Mac also has Docker support, or there's a Docker desktop capability. So I think running everything I did today on a Mac would be straightforward.
Cool.
And yeah, so there's
I could
Rust
I could
code.
actually see it on a. What do you think about like a Raspberry Pi, a single board computer, Orange Pi?
Yeah, actually I have it done. So separately from this work on the electronics, I have worked with some teachers who are using this system for robots that they have for some of the classes they teach, and they have been using Raspberry Pis. So that's a long way to say that I have done this whole setup on a Raspberry Pi before. The main thing that can be a problem with Raspberry Pis is if you have building and flashing happening, like you see in these little terminals, that's all happening on the Raspberry Pi. And that can
RAM,
sometimes,
yeah,
it can be intensive on the Raspberry Pi. So there'll
so
be some of
it'd have to
okay.
be an 8 gigabyte RAM would probably be able to handle it. Definitely.
Mhm.
You could also have the whole Raspberry Pi and Pico software development kit embedded right on there, and that just works perfect together.
Yeah. Well, yeah, one key idea with what I showed today is that you can make an image that has almost everything ready to go for the example code. And so when someone uses your sandbox and they work on the code and then they build it and flash it, almost everything is already built, or at least everything's installed and ready to run. So yeah, the main time constraint practically is that they have to build the code to run it or to flash it to the device. So yeah, that could be a problem in some Raspberry Pi hosts. But
And if I recall correctly, I know, and this is a long time ago. I'm kind of playing around with this. And there was a USB issue, I think, with Raspberry Pis when I was working with it. Something was-
J-Link,
I-
They have a different
Yeah.
way. Yeah, and even if you do an LS USB, it's kind of like a different. The mapping can be a little bit strange, but yeah, that the exact code you're running right there, where you're opening up the ports and stuff, or
Mhm.
mapping to the devices, that might have to change a little bit for Pis, even though it is Ubuntu. Yeah,
Mhm.
yeah.
yeah.
And it does show up as a, well, that's the device there, is a Silicon Labs, but yeah.
Mm.
Hey, I'd be willing to, I have an extra one to spare if you want to check it out. So,
Sounds good.
all right.
And so if someone wants to, wants to get involved with this, they could just hit you up on Discord. Is that,
That's the best thing. And if I'm not responsive, do not hesitate to send me multiple messages. There's someone actually who's did a sign up so there's a website that just has a sign up. If you go to hardshare.dev, and actually I've received a few signups over the months, and I've been very slow to reply. And so I'm here. I've just not been able yet to do 100% time commitment, but I will follow up. So
Cool.
yeah, you can sign up here. You can reach out on Discord. You can find my email address. Generally, I'm open to any kind of way of reaching me except showing up randomly at my apartment. That might be a little scary.
right, yeah. No, I understand you're busy, but thank you so much for presenting this. This is neat stuff, and I'm excited to get some whiz blocks in an array, and put that out where folks can use it. It makes it very easy to jump into firmware development. So neat.
Sounds great. Thanks for the opportunity. Thanks for everyone.
Oh,
Thanks everyone for listening.
absolutely. And I guess we ran just a little bit over. I've been trying to keep it to around an hour. Does anyone have any questions while we have Scott here, though?
I actually have one.
Okay.
So, Scott, is there a workaround for boards that need to be jumped to Flash?
There's not. And I'm happy. Yeah, this has come up on a few devices, and I don't have a good answer, honestly. I'm happy to use your case as a motivating case. I think,
An external relay.
right. Yeah, that's one answer.
That's the only way I could patch it.
Yeah.
Regardless, thank you very much for your work, man. It seems great. I'm going to check out the docs tonight, and I'm looking to try and get a few boards hosted. So
Cool.
I'm excited. It seems super cool.
Thanks. Excited to have you. I'm excited to have you. Yeah. Okay. Yeah, thanks for your patience. We went a little bit past the hour. You're right, Travis. I should have more discipline.
Yeah, but no. This was great, and thank you again for presenting on this. And I encourage everyone to go through the docs, look at the quick start guide that you have up, and start playing around with it. Scott, thank you very much. Everyone else, next week, same bat time, same bat channel. Everyone be safe. I'll see you then. Adios, folks. Bye.